definition, we can say that the odds ratio is a statistical measure mostly used in epidemiology in order to express the degree of dependence between two qualitative variables. So in odds ratio analysis, we have two qualitative variables that we are going to search for the link between the two. Odds ratio can be also defined as a ratio of odds of events that happen in the individual group A, for example the disease, with the same event happening in the group or in the individual group B. So what's odd? Odd is a ratio of a probability of an event and a contrary of the event. So if the probability that the event happened in the group B, in the group A is P, and Q is probability in a group B, odd ratio is calculated as follows: odd of the probability that the event happened in the group A and odd of the probability of the event in the group B. How to compute really odd ratio? We have, for example, a disease, some person that are affected by the disease. So there are A person that are affected by the disease and exposed to B person didn't have a disease but are exposed to the disease. So we have two groups, the group of exposed and the group of unexposed to the disease. We have a group of affected, that's called cases, and we have a group of control, that's the person that didn't have a disease. So if you have this contingency table showing the relationship between the occurrence of the disease and our factor, that is a group of exposed or unexposed to disease. A group of exposed or unexposed to the disease can be a group of male and female person or any other variable that can be used in order to express the link or the dependence between two variables. And so the odd ratio is calculated as follows: we have E over C divided by B over D. So you can also have this relationship A times D divided by B times C. So in this case, the probability that disease occur in the group of exposed is A divided by A plus B. The probability that the disease occur in the group C, in the group B or the group of unexposed person is C, the number of person exposed among diseased person divided by C plus D. That's the total number of exposed persons. So the odd ratio is calculated as odd of probability to belong to different group. That is same relationship that we show you very earlier in this tutorial video when we take this P and Q variable of our probability to belong to the exposed and unexposed group. So what's the interpretation of odd ratio? We have the interpretation. When the odd ratio is close to 1, the event is independent in the group. That means that if our main variable is a disease, like the previous table that we show you earlier, we can say that if the odd ratio is close to 1, that maybe disease and gender are independent. Gender didn't significantly influence the occurrence of the disease if we have the odd ratio close to 1. But if you have a contrary odd ratio that is superior to 1, we can say that the event is most frequent in the group A than in group B. That means that belonging to the group E is at risk. When one tend to belong to the group A, increase your probability to have a disease if you stay in epidemiology situation. And the other situation is when we have the odd ratio that is higher than 1. So that means that the event is hugely most frequent in group A than in group B. So we have already a case where the odd ratio is inferior to 1. We can say that the event is less frequent in group E than B. What that means that when you are in group B, you tend not to develop a disease. And the last case, in the case when odd ratio is close to 0. So that means that the event is hugely less frequent in group A than in group B. So let's take an example in order to illustrate the practice how and use odd ratio in order to interpret a risk factor. We have a sample of 200 individuals in which we have 100 men and 100 women that have drunk wine in ongoing week. So we define our main variable, that is alcoholism. Like you are alcoholic if you have drunk in this week while you have drunk in the previous week. Every person that we have selected have drunk in the ongoing week, and person that didn't drink in the previous week are supposed to be non-alcoholic. That is why how we have defined our variable alcoholism. So in our sample we have 19 men that have also drank the last week that are alcoholic, and only 10 of the 100 men have not drunk on the previous week. And let's look at women population. If you look at women population, we can see that 20 women in our sample have drunk in the previous week among 100 men that have drunk of the current week. So we can calculate the odd ratio, and we found that odd ratio is 36. That means that being men is a risk factor of developing alcoholic factor. That also means that in the group of men, alcoholic is 36 times more higher than in the women population.